That variable speed drive on the old Wells Index needs some attention. That was kind of weird what that just did. But that's a whole nother story for a whole nother time. Alright, so I guess I should explain what the hell I just opened this video with. So what you basically saw me doing was dealing with this connector that I cut off of my other TIG welding cable because, well, after I cut it off, I got to thinking about things and I started to wonder, started to doubt myself. I started to think that maybe I really did royally mess up here. So, oh, sorry, I didn't mean to get distracted. I just noticed that I damaged this when I had this at some point in the vise and I was banging on it. I might have to run a file or a stone over that. Anyways, let me get back to what I was doing with this thing. So this is a crimp connector. So I started to think, well, maybe I could salvage this connector. First, for anybody who wants to tell me that, hey, Steve, they sell those connectors, I know that they do sell them, but like the cheapest way to buy them is to get the slow boat from China delivery on eBay. And even then, these run about $6 or $7 a piece. And the problem is it's kind of hard to figure out exactly which one you need. You know, I just ran into that whole ordeal with the, well, that's another story. Anyways, let me back up for a second. So anyways, how do you reuse this crimp connector? So I went online and I actually, you know, started looking around and I found people talking about how they were able to do it. Well, one guy said he basically worked at it with, you know, picks and a hammer and just working at it and until he was able to pry this open enough to actually get the remaining copper braid out. And so my thinking was, when I couldn't get that to happen, I resorted to, I basically milled out a slot with the end mill. And I milled it out deep enough so that the floor of this slot is still present. So that will act as a partition, because this side is the side that the water flows through. It's this little trough right here. So hopefully, for those of you who haven't been watching my other videos in this series, there's a slot right here. Oh, let me get the light. All right, so there's a slot right here. Okay, and the water flows through that. And then there was a hole in the end here that the copper wire would sit inside here, and then it was crimped into there. That makes the electrical connection. And then, so you have the electrical connection on this side, and you still have the water being able to flow through there. And then the water flows around the outside of the copper conductor and helps cool it. So I began to think that there was something wrong in this cable because of my flow issue. Now, what I neglected to take into account, and why I believe that I may have, in fact, made a mistake here, is because, so I didn't like how the water was coming out of this return line into the tank. It seems to just be kind of like falling down into the tank, and it didn't have much force as compared to the amount of force of the water coming out of the pump, which was pretty significant, as I had shown in my last video where I did a test and I held the hose, the output hose, directly into a jug, and it was, you know, really spraying along in a really good clip. Like a fire hose, I think I described it as. Well, here's the thing I thought about afterwards. When I took this all apart and was playing around with the hose, you know, I quickly came to understand how small these tubes are. In fact, you could almost describe them as almost like capillary tubes compared to the hoses, okay? Very, very little small diameter tubes, and you can imagine the ID on these tubes is even smaller than this, all right? So, if you look down, matter of fact, if we look down in there, we could see the size of that hole. So I got this little pick doohickey here. Let's just look at the handle of this in comparison. So we got the handle of this in comparison to the hole down in there. Okay, it won't even go in there. You know, This is roughly the diameter of one of these tubes. All right. If we look down into the head of the torch, again, very small orifice. This won't go inside of it. Okay. If we look at the connector block, okay, the power block as it's called, this is where the torch, the other line from the torch, when it comes back, the one that I basically messed up here, okay, that goes into here, okay. The diameter of that is large enough for this to go in here, okay. So what's happening is we're coming from these very, very small diameter tubes, and all of a sudden when it gets to this point here, it opens up into this larger diameter hole, and then it goes into here, and it goes into an even larger diameter hole in here, okay? Comes out and goes into the hose, which if we look at this, it's even bigger. So what we've got is we've got this very small diameter high pressure that suddenly at the power block here transitions into this larger diameter hose. So I should expect a pressure drop, and I think that's where I'm getting hung up here. I think I may be chasing a problem that isn't even a problem, is what I'm getting at. So anyways, so you guys know I already ordered the I ordered a replacement cable. Okay, so I got that on the way. In the meantime, I went back. I went and looked in my shed out there, the Alpine shed thing, where I store a lot of my overflow junk, and I was digging through items there, and I came across, oh, and by the way, I want to give a shout out to Mr. Scott Henyon, because one of Scott's comments jogged my memory. Scott made a comment about the timer, the post-flow timer, the mechanical post-flow timer on my welder. And he mentioned how he says, oh, he said, interestingly enough, that he has an electronic timer on his. It mounts the same way. And then he referred to another individual, I guess, who's probably on YouTube somewhere, who also has one of these welders. And he's got apparently even a newer version, and it's got an octal base relay. So let me show you what that looks like. So I go in my bag of tricks I never throw away, and we've got, okay, this is an octal base relay. They call them an octal because there are 8 pins, and then this plastic pin in the center, it's actually got a little ridge on it so that it's keyed, so that when you plug it into the socket that this goes into, it actually can only go in one way, so you can't inadvertently put it in the wrong way. Okay, so that's a regular relay, nothing special about that. The octal base is also very popular for older vacuum tubes. And actually it's still in use today. Your 6L6, I believe, is an octal base tube. 6L6 is a very popular power amplifier tube in guitar amplifiers. So this little slice of heaven right here, this is a time delay solid state timer, they call it. But what it essentially is it acts like a relay that you would plug in to one of these octal bases, okay? And what it does is this one actually has on and off. So some of them are on only, some of them are off only, or some can be either, depending on how you wire it. They can be one or the other. This one actually can do both. Okay, so you can see you can have this on for a certain amount of time, and then you can have it off for a certain, or you can have it off and then turn on, vice versa. But that's what that is. So apparently the newest version of post-flow timers that at least Scott has seen is more like this. I haven't seen the one he's referencing, but I'm assuming it would probably be an animal just like this. Okay, but let's get back to what did he jog my memory about? Well, he jogged my memory about that old Bumblebee, Airco Bumblebee. That was the DC only 3-phase humongous amp welder that I bought off of eBay down in Rhode Island, dirt cheap, because nobody wanted it. But I saw what was with it and realized that if I took all the stuff that I wanted to keep and threw everything and just scrapped it and kept some spare parts that might be the same as what's in my Airco, and scrapped the rest of it, that I'd probably come out, okay. And I think I did. I don't remember that whole series. Those of you who want to see that series, you just look at my videos and search Airco Bumblebee, and you can see me talking about how I acquired it, what came with it, and I think I even talk about what I ended up getting for it. At the time, the big, huge transformers in there, they only gave me what they call the ballast rate, which is very low. I think it was 12 or 15 cents a pound. But the things were so heavy, I still got some, I got a few bucks for them. And the thing is, it came with a really nice long cord that was undersized for that size welder, but it sure makes a nice number 10 wire. Sure makes a nice extension cord that I turned it into. So I had to go back and look, because when he got me thinking about that other welder, I said, oh, I gotta look. I got parts for that welder that I kept. So I went looking, because I was like, I think I might have gotten another torch with that. And I was like, I think I might have gotten an air-cooled torch with that, and I could actually throw the air-cooled torch on and start using this thing now while I'm waiting for my water-cooled cable replacement. So a couple of days I go out there and I'm looking for this torch, and what do I stumble upon? But I stumble upon this. So while I'm rooting around in there looking for that TIG torch, which I couldn't remember if I even got one with that thing or if it was air-cooled or whatever, I came across this, and it's like, oh, cool, all right. So here are the solenoids that I saved. They're a different style solenoid, but they do the same thing. And then here is a electronic timer. Now, it's sort of solid state. It's interesting. It's a relay on a PC board with several other components, and there's an IC chip in there, so there's probably a timer. What do they call it? 777 chip or whatever the heck. I don't remember. It's been a long time. But anyways, so we got this nice timer unit here. So I'm thinking I might want to just do a little sprucing up on this thing and put this in my welder, because I think this might end up being more dependable. Why is it so important that the post-flow timer be dependable? Well, if you stop welding and your contactor opens and you immediately have your gas solenoid close, that's not good, because then you're going to have no post-flow argon shielding the weld, and as the weld bead cools, you can get oxidation. Secondly, the other thing that could happen is if you have a problem with the timer where it continues to hold the gas solenoid open, well, then you're wasting gas, right? And that's not good. So I think I might just do that. So look, probably in the near future, I'll probably be dissecting this, taking a look at it, cleaning. What I want to do is more than likely change these electrolytic capacitors, clean this potentiometer, and then just test this unit and make sure it's working okay. Oh, and while I'm talking about post-flow and relays, I just want to mention that now I've had a second person who's commented and wanted to let me know that there's really no need to use the coolant relay at all in my setup, because I have a recirculating TIG torch cooler. And one of the people had mentioned that they said that they believe that the purpose of this solenoid was for in situations where people are just running a line from the tap water up to this, and so that there was a way to leave the faucet on and basically have the flow turned on and off by the solenoid. But since I've got this recirculating system where literally the flow is going to go up to the torch head, come back, go through the power block, and then go back to the reservoir on the cooler, there's no reason why I couldn't just have that circulate constantly. There's no downside to having it circulate constantly. As a matter of fact, it'll probably keep the torch cooler in a way, because normally you stop welding, your torch is pretty hot. You've got post flow, but if you've only got the post flow set for 10 seconds, well, that's only 10 seconds worth of coolant flow before the coolant flow stops, so that the torch is going to cool down some. But if I omit using this solenoid and timer to control my coolant flow, I could just have it basically flow coolant all the time. The only drawback to that is the noise from the cooler, but I know a lot of people complain about the noise from their coolers. Different coolers make different noises, I'm sure. But in our case here, me and the mouse in my pocket, that Airco is the cooling fan on that thing is huge. It's like 15 inches in diameter, and it throws a ton of air, and it's loud. And that's even before you put on that HF with the spark gap. So anyways, the point is, I'm not really worried about the sound from the cooler, but I am going to wire a circuit so that the 120 volts that runs the cooler is going to come off of the control circuit in the welder. I don't want the cooling pump to shut off when the contactor opens, because, well, then I've got no post flow cooling, right? Basically, that's exactly what I don't want happening. That would be that the coolant stops pumping the second that I stop welding with the torch. I don't want that. But it would be nice if if the cooler shuts off when I shut off the welder. So, all right. So that's what we got going on there. So let's see. So I talked about this, talked about that. Oh, okay, yeah. So getting back to the torch. So I'm looking online and I'm like, okay. So I see guys. First, I think, all right, maybe I'm nuts about this whole problem with the cooler, with the cable and the torch being restricted, and maybe I'm just overreacting. So I'm thinking, well, maybe I should do what some guys have actually done, which is actually repaired and reused this connector. So you saw I milled out this slot, okay, on this side. So I'm figuring, okay, all I got to do now is, I can't really re-crimp this. I guess I could try. It's not really going to really crimp down, but I figured I could solder the cable into here. And then the way that would work is you'd pull back the sheathing far enough, solder the cable in, and then slide the sheathing or the outer tubing back over it, and then retie it with a piece of wire. The same way that it was on here before. Seems simple and straightforward enough. Well, interesting thing happened. So I'm thinking, all right, why don't I do that, right? And I'm thinking, well, is that even plausible? Can that be done? So what I did was, I was thinking about how this would have to be done. And essentially what ends up having to happen is you have to pull this cable out, and you have to kind of stretch this cable out and slide this back, okay? Because right now you can see that the cable's a lot longer than the outer tube. So there's no way in heck, if I solder this on like this, for instance, okay, that's not going to work. Because then I got to get this to, go in there, and that's not going to work. So what you got to do is, ideally you would cut this off pretty close to the end here. Then pull this cable out as far as you can stretch it out. Okay? Then solder it on. And then when it snaps back, hopefully you'll be able to pull this outer hose up over to this point and clamp it. Not exactly an easy trick. But here's what I just found out. I wish I had checked this before I even bothered doing this, because look what happened when I pulled this out. Watch this. All right? So watch when I pull this out. Look at that. Do you see that? The cable's damaged. It looks like it's either corroded but it's damaged, it's broken, and here is a chunk of something. I don't know what that is. Let me see if I look at it under the magnification, if I can see what this is. I don't know, but there is some crud in there, okay? It looks like hell. Look at the corrosion. So what I'm going to do is, now because I see how bad this is, and because this is a 25-foot cable, I'm going to slice this open with a utility knife and get a look at this cable. Because if the cable inside this tubing, if it all looks like that, then I sure as heck did the right thing in assuming that I need to replace this cable. All right, so it looks like that damage is only right here at this area here. So what appears to have happened to me is that this has corroded maybe, and it broke. All right, I don't know whether or not this got twisted or what happened, but if you look, you can see this is all frayed and damaged. If I pull this back further, this actually doesn't look too bad, this cable. So I think maybe it's just this area at the end here that was damaged. But you know what? Maybe that bit of damage and this, what was going on the end here was enough to cause some kind of a restriction or clog this, because there was that weird material that was in here. If I open up the sheathing and look inside, it's got some residue in it, but it doesn't look too bad. So another thing I found online was some guys actually have used CLR. I don't know if you guys are familiar with that product. That's a calcium, lime, and rust remover type of product. But they've actually pumped that through their torches, their lines, and their heads in order to remove any buildup. So I'm going to probably try that on my old torch head. And, I also have decided to invest to plop down the $40 or so. With shipping, it was almost $40 for a gallon of, I think it's called Defense 929, which is the suggested coolant, TIG torch coolant by the manufacturer for my Dynaflux cooler. It's also marketed, I think Weldcraft markets that same product. Matter of fact, I think it's coming in as a Weldcraft Defense 929. But anyways, that's what's going on here. So I'm tempted to still maybe try and fix this. I don't know. Oh, so now that I cut away this sheathing here, kind of explain the whole process of making this happen, if I'm going to be able to get it to happen at all. Essentially, you push the cable in a little bit, and you're going to cut this off. Cut it off with just a little bit exposed, just enough so you'll be able to grab onto it. Then I'm going to pull this out like this, okay? And then I'll probably put a clamp on here to keep this out. Solder this on, hopefully not overheat this hose in the process, and then once it cools, this should be able to snap back and be pushed over onto that, if that works. Well, I'll be the first to admit I'm not thrilled with my solder job here, but it occurs to me that, alright, so the battery on the camera died right while I was working, and so I had the torch and everything going, and I didn't want to quit. I ended up through trial and error, I ended up eventually getting that solder to work. I ended up having to reduce the amount of strands of wire in order to get it to fit in the channel. So I cut back part of the center conductor further. And then when I put it all together, the effect should be that it's actually pushing that wire up against the back of that and making a connection. Furthermore, I almost wonder whether or not I even needed to solder this at all. I actually saw somebody online talk about how they just stuck the wire back in there, and when they pulled the tubing over it, the tubing clamped down on the wire and held the wire in place. And now that I see how tight this is, I have to believe that maybe that actually would work. This is as far as I can get this outer tubing to come up onto this barb. I've tried now for a while to push this any further, and I just can't get it to go any further. I've blown into this now, and I actually do think that there's less resistance now. I could be just, delusional, but I think what I'm going to do, I'm going to try just a little bit more to get this wire on. The other thing is, too, is if I keep pushing this too far, I could end up kinking the wire at the end here, especially the cut strands, and causing an obstruction again. So I don't want to do that. I'm certainly past the point where the hole is there, so I think right now this actually would seal. So I think what I'm going to do is see if I can't get a little piece of wire on here and tighten it down as a little clamp, just like what was on there. All right. So what I did is I hooked the hose that goes to the power block here directly to the output of the pump. So this way I'll be putting quite a bit of pressure into this joint here, because if it's going to blow at that high pressure, then I know it wasn't a good fix anyways. And furthermore, I left this line disconnected at the torch, so essentially the water is only going to be coming out of the cooler, going through this cable line and out here into my jug. And I'll be able to see. This should spray like crazy. Probably take a second to prime. Well, that's weird. It's just going on bypass. It's bypassing. What's going on here? I was just able to blow through this a minute ago, and now no water wants to come out of this thing. There's got to be something wrong with this cable. This is gravity flowing. What if this cable is damaged somewhere else, and just moving it around is causing it to like kink up or something? If I can blow through this again now. It's weird, I can blow through in one direction easier than the other. Shouldn't be any kind of a check valve. Alright, so I just hooked up the other end of this line directly to the output on the pump, which this line doesn't have the cable in it, so it shouldn't have any obstructions. Just for the heck of it, check, make sure my pump is able to push through this. Let's see why it wouldn't. It's going to be a little tricky to get this to go in the jug here. Yep, that sprays well. And now I've reconnected this connection here, so that's going to force the water back down my line that's acting kind of screwy on us, which is way up here. So I gotta hold the jug higher. There it is. And it's just a little dribble. See how bad that is? It still appears to be pathetic. Yeah, I still think there's something wrong in that cable. Well, maybe when I get the new cable in, I'll do an autopsy on that cable and just cut it open completely and see what I could find inside. Oh, so I talked way back in this video I mentioned Scott Henyon reminded me of something. He reminded me of the fact that I'm pretty sure I had another torch. So when I first went out and couldn't find it, I found that timer assembly and everything. I couldn't find it. It was bothering me. So I went back and I actually looked at my own video and saw where not only did I have another torch that came with that welder that I scrapped, it was a water-cooled torch, a Weldcraft. And so I went back and sure enough, I found it. I had put it inside of a tote box and I thought it was just hanging out in the open somewhere, and that's why I didn't see it the first time. But when I was confident it was in there somewhere and searched, I found it. So it's a Weldcraft. This is broken on the back here, and they taped it with electrical tape to keep the gas from leaking out. But that's easy enough to get a replacement one of those. The problem with this torch is when I blow into, this is one of the water lines. When I blow into this water line, I can hear air leaking out right along here somewhere. This is kind of like a weird, funky cloth braid hose, but this is leaking, so this hose is bad. And when I try and blow into this red hose, which goes to the power block right here, which is kind of funky on this one, a little bit different, I can blow as hard as I want, and I can't get anything. So this apparently is a bad, completely bad hose also. So the only thing this is possibly good for is maybe the torch handle, and even that's kind of, you know, it's a little beat. So oh well. So it looks like I'm gonna have to wait until my new stuff comes in. Oh, see how this has got a rubber sheathing that protects the hoses? I actually bought a nylon one of those for my other torch there, so that when I put the new hose on it and hopefully get that all rectified, I'll be able to cover it with one of those nylon sleeves to protect it. So alright, that's all for now.